many positive 3-digit integers have a remainder of 2 when divided by 6, remainder of 5 when divided by 9, and remainder of 7 when divided by 11. So we have 3 remainders and 3 divisors in this case. So let's discuss a plan to solve this problem. First we will see the concept, then we will look for some hints, and at the end we will find the solution. This type of problem is very important for several mathematical Olympiads from all over the world. This problem made its first debut in AMC 8 2018 problem 21. Hi everyone, this video is sponsored by Chinta.com. This video is actually based on number theory concepts. I am Sayantan Chakraborty and I am a content creator at Chinta. Now let's look for the concept. Having 3 divisors at a time, the least we can do in this case is to think about the least common multiple. But wait, before doing that, let's find a pattern. Now what we will do, we will subtract remainder from divisor, which means in our problem we got 3 remainder and 3 divisors, so we will get 3 cases of subtraction. First we will subtract 7 from 11 and we get 4. In the next case we subtract 5 from 9 and we will get 4. In the third case we will subtract 2 from 6 and we will get 4. Now we get a pattern of 4, like every subtraction is giving the result 4. With this fact we can form the general formation of numbers for our problem, which is 11k minus 4, 9k minus 4 and 6k minus 4. We have to remember that this is the general formation of numbers. A little bit about Chinta.com. Chinta is running since 2010 with brilliant students at mathematics, ISI CMI entrance program which are taught by Olympians and researchers at Chinta. There is also a free toolbox where we post several problems for everyone. The link is in the description. Now the first hint. Find the least common multiple of 11, 9 and 6. So the basic thing we have to know to complete the first hint is the least common multiple. But before jumping to the main problem, first try to solve one example. We are supposed to find the least common multiple of 2, 3 and 6, which means we have to basically list the multiples of 2, multiples of 3 and multiples of 6 separately. After listing, we can see that 6 is the least common multiple. Now coming back to our problem. We were asked to find the least common multiple of 11, 9 and 6. So we will do the same thing. We will list the multiples of 9, we will list the multiples of 11, we will list the multiples of 6. After doing that, we get the least common multiple of 11, 9 and 6 as 198. Now this is a very boring and a long process. Let's see one interesting way. According to the fundamental theorem of arithmetic, a positive integer is the product of prime numbers and this representation is unique up to ordering of prime numbers. Suppose we are taking a positive integer q and we are breaking it into its prime factorization and we can write it as the product form. Here we have to remember one thing, this p is actually the prime numbers which are present in the prime factorization and the exponents q2, q3 ... are non-negative integers. Now when we will try to find the LCM of a and b, we can use this formula. Now this formula looks a very complex thing for us. But when we are using it, it becomes very easy. So to find the least common multiple of 11, 9 and 6, we have to break each of them into their respective and unique prime factorization. After doing that, we have to take every prime number present in the prime factorization and we have to find the max of their products. The max here means the max of 1 comma 0 comma 0, which is the maximum of these three, so it's obviously 1. By similarly doing this for 2, 3 and 11, we get the same result as 198. This way is very easy than listing the multiples, as we can save a lot of time in the Olympiads. A big shout out for everyone who have subscribed and share our works. Please subscribe us more so that we can produce various kind of video for all the mathematicians. Now, second hint. Is 198k minus 4 satisfying all the conditions? This 190k minus 4 type we got from the general formation. Now, solution. Let's find the 3-digit integers. We will take some values of k and we have to see that which one satisfies the condition. Okay, so 6 values, 1, 2, 3, 4, 5, 6. Now 198k minus 4, we have to put these values of k and we have to see that up to which value of k we are getting a 3-digit integer. Numbers. The first one, when we are taking k as 1, we got 194. Next we take k as 2, we get 392. We take k as 3, we get 590. We take k as 4, we get 788. We take k as 5, we get 986. When we are taking k as 6, we are getting 1184. Now we are almost done. Now we have to just count the number of 3-digit numbers, which are 194, 392, 590, 788 and 986, because when we take k as 6, it's exceeding 3-digit numbers. So that's all. This problem was very easy and very interesting and it's quite easily done. Thank you.